Okay, here we are with truth tables and logic expressions moving into Unit 2. And these next three sections are what you would call the trilogy of logic. What we have are truth tables, logic expressions, and then what combination of logic gates does it take to make the circuit. Okay, so this is going to work. Okay, so what are we looking at today? We're going to look at sum of products, logic expression from a truth table, write a truth table, writing out a truth table, and going back and forth between those two. So like here, we have a truth table, and what we see in this one is what's on. We see there's only one output of a 1. X is on, Y is off. So we would read that as a logic term of X, Y naught. Okay, to do a not symbol, we can put a bar over top. Sometimes you will see, instead of the bar over top, because it's easier to do, sometimes you will see X, Y apostrophe. Okay, because it's a little bit easier to type that. So either one works. Just got to be careful. I like writing the bar when I'm writing it out by hand. It's a little bit more clear. Okay, everybody with me on this? All right. So, of course, a truth table, and I think I've already talked about this. A truth table goes along with binary numbers. So, if we have 2 inputs, how many lines are going to be in our truth table? 2, 3, no. 4. If I have 2 variables, I'm going to have 4 combinations of numbers. If I have 3 variables, I'm going to have 8. If I have 4 variables, I'm going to have 16. If I have 5 variables, 32, and then you're going to hate me, right? Because then your truth table would be 32 variables, 32 lines long. We actually don't. Okay, 2 powers of 2. So it's still binary numbers. Okay, so right, logic design with n inputs, we'll have 2 to the n combinations in your truth table. Okay, and we always do them in binary number order. So what do we got to do? We got to look at our terms. So here with 2 combinations, we got 4. And we look at that like on this one. What is turned on here? What would be my term for that first one? Not XY, but AB. Okay? The only one that has an output is the last row, but with 2 combinations, 0, 0, 0, 1, 1, 0, 1, 1. The only one that has an output of 1 is AB, the very last one. Okay? If we have that next one, we won't do all of these, but we've got quite a few ones, don't we? We have 3 different ones. Now, what is that called? That was F3, not F2. They just use a subscript to make a distinction between the two. Okay, so if I look at that, I would have what X is off, Y is off, Z is on. So that's X naught, Y naught, Z. Or my next one is what X is off, Y is on, Z is on. Or my third one is X is on, Y is off, Z is on. Okay, and that's what we call a sum of products expression. Okay, of course, they're shown, and notice we already kind of looked at this with other truth tables and writing out binary numbers. What's our least significant bit? Always toggle 0, 1, 0, 1, 0, 1, 0, 1. The second bit goes 0, 0, 1, 1, 0, 0, 1, 1, right? And the last one, 4 zeros, 4 ones. And if you have 16 combinations, your most that has 8 zeros, 8 ones. It's real easy to write out a truth table. Those little terms, and we just did a couple of those, each one of those terms is called a minterm. A minterm. And the sum of products expression is ordering all of those together. Okay? Let's have you help me out a little bit more. Yes, this is F6. So what do I need to look for? I need to look for where do I have outputs where I have ones. Got an extra yellow line there, but whatever. Okay, what's my first term here? Carson? What's my first term here in the second row? What's my term? Represented by all these things. How would I write that down?
Oh, you're telling me to do that one?
Yeah!
Oh, okay. Not A, not
Okay.
B, not C.
Yeah, I'm just asking, I'm making sure you're with me, that's all. What happened to my pen? All right, so, all right, go again.
Not A, not B, not C.
Okay. Jenna? Or Addie? Yes, you could, if you were typing it on a computer, you could do it possibly. We're gonna do most of these assignments handwriting, okay, in our notebooks. That's why we have them. But and the other thing, you were saying not A, not B, not C, D. How you say, and you can say it that way. You could it's just spoken. You could also say it as A naught, B naught, C naught, D, instead of not A, not B, not C, not D. And so it just depends, how do you want to say it, and how are you pausing when you're saying the term out loud to not confuse who's listening to explain what the term is. Does that make sense? And the other distinction we have to be really careful of is, you can't do this. A, B, C, and A, B, C, D is not the same as A naught, B naught, C naught, D. Those are very, very different. Okay? And that's something we'll get into and see and explain why later in the chapter, but probably not till that'll be after Simulbot before we start looking at that. Okay? Who's up next? Julia? A, B, C naught, D. Or last term, Braden? A, B, C, D. Okay, it's like Michael Jackson, right? It's easy as A, B, C, 1, 2, 3. Okay. All right. So, what we also want to be able to figure out is if we have the logic expression, can we write the truth table? So here, and this one's already done for us, but what we have is we have a couple terms that give us a single term. We have x naught, y naught, z naught, which is, of course, my first row. And I have x naught y z, which is my fourth row, binary 7. No, binary 3, I mean, binary 3. But then we have x z. Now, in that term, it only has 2 variables, right? So what does that mean? X has to be on, and z has to be on, and we don't care if y is off or on. So that term gives us 2 different outputs in my truth table. Okay, and that's also something, this would be the same as listing those terms separately, but this expression is a little bit more simplified. And that's also something we won't talk and do a lot with until after the Sumalbot term. Because, right now, between now and then, we'll be doing these next 3 sections and having a quiz, but then we got to get ready for the Sumalbot tournament and finalize that after Thanksgiving. So, here is what we got. Create a truth table for this whole expression. Well, first of all, you have to, and you will get fast, you should be fast at writing out truth tables. And that's one of the reasons you've got graph paper in your engineer's notebook. And if you all only want to do it on your square grid paper instead of ISO paper, it's real easy. Because you put a 1 and a 0 in every box and put a label on it and we go. But what's my least significant bit do? It goes, well, those are all zeros, but it goes 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. And my next bit goes 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. And then we got 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, and then we've got 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1. And remember, what is this? This is decimal number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay? So, A, B naught, C, D. Where does that end up? Yeah, 11. A, B naught, C, D ends up in 11. A naught, B naught.
0, 1, 2.
Yeah, 0, 1, 2, 3. For A naught, B naught, that's 0, 1, 2, 3. A, B naught, C naught, D naught.
7. 7.
8.
So I looked at it backwards.
You looked at it backwards. Okay. Well, that would make a difference, though.
Yes.
That's 8. And B, C naught, D.
5. 5 and 13.
B, C naught, D gives us 5 and 13. And we don't care what A is. Oh, why? Because you said 5, so I wrote 5, right? It will be a 1. Thank you. And then what do we need? The rest of those are all zeros for outputs. Okay? And then, is this, this is just like basically level 1 problems, depth of knowledge. Level 2, depth of knowledge, or it could even be level 3. We could get into a situation where we have an application problem. So what do we have is we have, let's see, we have our teacher keeps her final exams in her office, and for security reasons, she would like you to design an alarm system for her office. It has a window and a door that are equipped with sensors that output a when they're secured. And when the system is turned on with a key, the siren should sound if either the window or door is secured or open. Okay, so I guess we got to figure out when are we going to have a siren. When are we going to turn on? Oh, I messed up. So we need to fill out our truth table. So, might help to define what everything is. If K is a 0, that means the system is off. If K is a 1, that means it's on. Okay, and what did they say about the sensors? The sensors output a 1 when they're secured, so when it's closed. So the window or the door output a 1 when it's closed, and they output a 0 when it's open. So when should we sound the alarm?
1 0 0 1 1 1 1
Yeah, so it's, if the alarm system's not on, we don't want to sound an alarm, right? So
4 5
So yeah, 4, 5, and 6. And then if the alarm's on, both the door and the window better be closed. Okay, so then what is my equation for S when I sound the alarm? Lance?
K D naught W naught.
Yeah, K, D naught, W naught, or Micah?
K D naught W naught.
Or K, D naught W, or Jaden? KDW naught. Okay, so that would then be the circuit we would need built. Now that probably simplifies multiple layers, but we're not worried about simplifying at this point. Okay, questions at this point? All right, dive into the assignment. We look at the whole thing, we've got, and just work it out in your notebook. You don't have to copy the truth table for 1 through 5. Just write them down. We'll go over them after you get some answers. On the next, are yours numbered the same way? 1 through 5, and then it starts over 1, 2, 3. Okay, that's it. So for those, yes, you'll have to write out your entire truth table. And then you have, after that, we have, that problem should be kind of familiar. The door key, they have you kind of look at that again before you try to tackle Aunt Mary's cats. We're going to check the environmental conditions for Aunt Mary's cats. Fur ball density, temperature, and humidity. Right? Well, that's even on the commercial now, right? For the college football. Isn't that one of the commercials for the college football mascots? They spit out fur balls because they're all cats. And then the dog shows up and spits out spits out a fur ball too, remember? The Georgia Bulldog.